Hello, class. This is Mr. Eggleston. This is like the third attempt. I'm hoping I figured out my iPad why it's not recording. So, everything's written, so I'm just going to go through it. Because this is like the third time I've gone through it. All right, the first question will be the type and number of solutions to a quadratic equation. All right, yes, there's a typo there. Sorry about that. You have three types. You have a graph that crosses the x-axis twice. That's two real solutions. All right, two real solutions. Why? Because a real solution is the x-intercepts of the graph. Also, when we talk about discriminants, it's when d is positive. All right, you also have the where the graph touches the x-axis at the vertex, and that's one real solution. And that's where the discriminant is 0. And the last one type is when the graph doesn't touch the x-axis at all, and there's no real solutions. Okay, no real solutions. All right, this is all based off the quadratic formula, which I will have on the board. X equals the opposite of the b plus or minus the square root of b squared minus 4ac all over 2a. The second question will be, given an equation, can you find the discriminant and then determine the type and number of solutions? Well, the discriminant is just whatever is underneath the radical, which is b squared minus 4ac. So for each of these problems, I'm just plugging the numbers into b squared minus 4ac and seeing what we get. So on the first one, if you plug negative 18 is b minus 4 times a times c, if you type it into your calculator, which you should have, you need your calculator, you get 0. 0 means the graph touches the x-axis at one location, at the vertex, as it turns out, because if the discriminant's 0, all you have is that, opposite of b over 2a, which is the location of the vertex. So you would say if you get d equals 0 by plugging in b, a, and c into the discriminant, which is the thing underneath the radical, you get 0, you'll say one real solution. On the next one, notice all I did was change c. I made it plus 1. So now, when you plug it in, right, negative 18 squared minus 4 times 1, you get a positive 320 if you do it correctly. Positive 320, that's a positive number, and if you plug and the square root of 320 is a real number. So you get two real solutions from that. Finally, if I think it was plus 100, I changed c to be 100. When you plug that in, you end up with a negative 76 for the discriminant. So in the quadratic formula, you end up with the square root of negative 76. Well, that's not real. So there's no real solution for that. All right, so those are the three types, and they're all represented here, right? You got your positive discriminant, two real solutions. Discriminant of 0, one real solution. And the discriminant being negative, no real solutions. Okay, question 3 is to solve these quadratic equations using the quadratic formula. I'll have it on the board, but it's right here. It's x equals the opposite of the b plus or minus the square root of b squared minus 4ac all over 2a. You just have to be able to plug in a, b, and c. So one of the big things for these is when you're given a quadratic equation is to write down right away what a, b, and c are. A is this, b is that, and c is that. So it's 3. Notice I'm keeping the sign negative 4 because negative 4 is in front of the linear term x. And then negative 4 from here. All right? So I plug it in with the signs. I use my calculator. Negative 4 squared is 16. Negative 4 times 3 is negative 12 times negative 4 is a positive 48. 16 plus 48 gives you 64. So, and then 2 times 3 is 6. So it's 4 plus or minus the square root of 64 over 6. Well, luckily for us, we know what 4 plus the square root of 64 is. It's 8. So it becomes 4 plus 8, which is 12 over 6. And 4 minus 8, which gives us a negative 4 over 6. Reducing, you get 2 and negative 2/3 as the solution. Okay. For B, I forgot I erased it, so this one I do have to write. A equals a half, B equals 2, and C equals 4. So X equals the opposite of B, plus or minus the square root, and I'm just going to blow it up a little bit here. B squared, it'll be 2 squared, minus 4 times a half times 4, right? 4AC, AC, all over 2A, which is 2 times a half. 2 times a half is 1, so this becomes negative 2 plus or minus. Now 2 squared is 4. 4 times a half, I'm doing this back piece, 4 times a half, you use a calculator, it's 2 times 4 is 8. So it's 4 minus 8 over 1. 4 minus 8 is negative 4. And we have this, negative 2 plus or minus the square root of negative 4. Well, lo and behold, the square root of negative 4 is imaginary. So to find the square root, we just pull the negative sign out. We think of it like this. Okay? And we know what the square root of 4 is. It's 2. And we know the square root of negative 1 is I. Oh, and then we get this, 2I. Notice our solution is complex. It has a real part and an imaginary part. In other words, this graph will not touch the x-axis. It's like whichever one didn't touch the, what was it, C? It's like that, where the graph never touches the x-axis. All right, so that's how you can use the quadratic formula. Here's another one. A is negative 1, right there. B is 6, and negative 9 is C. Plug it into the quadratic formula. You get this kind of weird-looking, ugly, numbered expression. But you have a calculator. You get the opposite of B is negative 6. Now 6 squared is 36. And then when you got negative 4 times negative 1 is a positive 4 times a negative 9 is a negative 36. So we end up with that. But we know 36 minus 36 is 0, and we know the square root of 0 is 0. So it becomes this, negative 6 plus or minus 0 over negative 2. This gives us, and I didn't write it, it gives us negative 6 over negative 2, which equals a positive 3. One real solution. All right? Now, about the complex solutions. If you have a complex answer, like this complex number, negative 3 plus 2i. If you're given that, and I say, what's another solution? You instantly know it's going to be the conjugate, which means you flip the sign between the real and the imaginary. So you flip the sign on the imaginary part. So instead of negative 3 plus 2i, it becomes negative 3 minus 2i. And that's another solution. All right? On B, if 2i is a solution, then negative 2i will be, because I was trying to show here was that 2i is just a 0 real part plus 2i. So to find the conjugate, we just switch the sign in front of the imaginary. So it'd be 0 minus 2i, and that's just negative 2i. So when you're just given an imaginary number, its conjugate is just you flip the sign. Likewise, if the number was negative 3i, its conjugate would be 3i. So just remember, it goes both ways. I just realized both examples had the imaginary part being positive. All right, simplifying complex numbers, when we're adding or subtracting. It basically comes down to this. When you're given two complex numbers and we're adding them, we're going to add real to the real. So 3 plus a negative 1, which gives us 2. And then imaginary to the imaginary. So that's 4i plus 7i, which is 11i, and that's the answer. For B, which was subtraction, okay, I always warn my students, and I'm warning you, when you subtract, add the opposite so you don't forget, you don't have to remember that negative sign there, because a lot of times you will. So then it just becomes just like the a, negative 4 plus negative 1 gives you negative 5. Negative 2i plus a negative 7i gives you a negative 9i. And that's the result. Negative 5 minus 9i. Pretty straightforward. Now when you multiply two complex numbers, and I pointed out these are complex conjugates, you just multiply two binomials. So however you want to do it. If you want a FOIL, first, outer, inner, last, and write them out, that's great. If you want to draw the box, that's great too. I like the box, especially for those who are just learning this. So here's the box. I got one complex number across the top, the other one down the side. So in the first box, it goes 2 times 2, which gives you 4. Second box is 2 times a negative 3i, which gives you negative 6i. Okay. And then in this box, we got 3i times a positive 2i, which gives us a positive 6i. And here comes the thing you got to remember. You got 3i times a negative 3i. 3 times negative 3 is negative 9. I times I is I squared. Don't forget the squared on the I. Now here comes the thing that you may or may not remember. You got to remember it for the quiz because it's a major, this is the whole point. I squared, this I squared is just negative 1. When you square I, you get a negative. So you end up with this, 4 minus, the i's go away. You got 4 minus 9i squared, which is 4 minus 9 times a negative 1, which becomes 4 plus 9, and you get 13. Notice the neat property of conjugates. When you multiply conjugates together, you get a real number out with no imaginary part. Okay? So that's how you multiply. I gave you another example here of two numbers that are not conjugates and how you handle that. Notice again with the box, I wrote 1 across the top, 4 plus 8i. The second one down the side, 3 minus 2i. I filled it in. 4 times 3 is 12. 3 times 8i is 24i. Negative 2i times 4 is negative 8i. And negative 2i times 8i is negative 16i squared. Add down the back diagonal. You end up with the 12 from here. And then 24 minus 8 is 16, and that's I. And then I tacked on the negative 16i squared. Now what I'm doing here is trying to remind you I squared happens to be negative 1. So that turns into negative 1. And you're left with 12 plus 16, 12 plus 16i, minus 16 times a negative 1, which makes it a plus 16. So then 12 plus 16 is 28, and you have 28 plus 16i. And that's your quiz. I hope that helped, and I hope this recorded. So you have a good day, and I'll talk to you soon.